Number 2 says, in a time use study, 20 randomly selected managers were found to spend a mean time of 2.4 hours. The standard deviation of these 20 scores was 1.3 hours. Construct a 98% confidence interval for the time spent on paperwork by all managers. So this is going to be a T interval. So it's going to be, we're going to take X bar, and we're going to add and subtract T critical standard error of X bar. Okay, that's going to be our confidence interval. We've got to find each part of that. X bar is the sample mean. That's given to us. What was the mean of our sample? 2.4 hours. T critical. That's T degrees of freedom. Remember, that's T n minus 1. What's n?
It's originally 20, but minus 1 is 19.
So the degrees of freedom is going to be 19. So we're going to go to our T chart. We're conducting a 98% confidence interval. So we're going to go to this fourth column. We're going to go to degrees of freedom 19. And we get a T critical of 2.539. The standard error of X bar is, when we're dealing with a T interval, we don't know the population, so it's the sample standard deviation divided by the square root of the sample size. What's our sample standard deviation? What's our sample standard deviation? 1.3 over the square root of 20. 0.29. So we're just going to fill this in. Our confidence interval is going to be X bar plus and minus T critical standard errors.
Do you want it?
Yeah, give me the subtracted version.
1.66369.
1.66369?
Yep.
Okay, so we'll just leave it at 1.66.
And then minus 3.13.
Hold on a second.
Oh, I put a minus in mine. It's 3.13.
Okay.
For my reasons, I put a minus.
Like a dash?
Yeah, like a dash. There it is.
So 1.66, if you round, is 3.14. Okay. Now, it does not say report the results of your confidence interval. It just says construct a 95% confidence interval. That's the answer. Now, if it asked you to interpret it, which it does not, but if it said interpret the 95% confidence interval, or 98% confidence interval, we'd say based on our sample of n equals 20, we are 98% confident that the number of hours spent on paperwork by all managers is somewhere between 1.66 and 3.14 hours. Does that make sense to everybody? Yeah. It's the same exact reporting, you just fill in the blanks. Based on our sample, n equals blank. We are blank confident that whatever we're talking about is between the low end and the high end of our interval. Number 3, we've already read through this. We've decided it's a 1 proportion Z interval. We're talking about 33% of parents take part or play in recreational activities with their children every day. That means we know P hat. P hat's a proportion. It's got to be between 0 and 1, a decimal between 0 and 1. It's not 33 people of a certain amount, it's 33%. How do we write that as a decimal? 0.33. That was another issue people were making on the test. They were wanting to use 33. It's 0.33. This survey was based on a random sample of 750 people. And that's all the information that's listed for us. So it's going to be, instead of X bar, it's going to be P hat, right? Plus or minus Z critical standard errors of P hat. We are creating a 95% confidence interval. So, if you don't know this, which it's 1.96, we know that one. But if not, here's the process. You say, I know between Z critical and negative Z critical is how much data? 0.9 what? 95. Because we're creating a 95% confidence interval. That means if there's 95% of the data between, then how much data is on the outside? 5%. And in order to know a p-value, we got to know the area to the left. So how much is over here in this tail? 2.5%. So yeah, 2.5%. So 0.025. So the p-value is 0.975.
You said you added those?
You add those two, correct. Because you need to know the total area to the left. So you take the 0.95 and then add it to the 0.025 to know the total area to the left of Z critical. Then you would go to your chart. 0.975 is a p-value. So we find that in the middle of the chart. And the z-score that results from that is 1.96. So Z critical is 1.96. Now once again, if it's 95 or 90, you should have this memorized. 1.96 is 95, 1.65 is a 90. But that's the process. So we know p hat, we know Z critical. Now we got to calculate the standard error of p hat. Standard error of p hat. That's the square root of p hat, q hat over n. P hat is 0.33. Maybe come over here. Q hat.
0.67.
It's 0.67. It's always 1 minus whatever p hat is. And then divided by 750. 0.43 times 0.8. Do what?
0.0178.
0.0178.
Yes.
I have 7.2.
Yeah, I do too.
I don't, but I want to bring.
You don't have
0.0172. Yeah. And then plugging it in is going to be p hat plus and minus 1.96 0.0712. We just type that in. 0.3 minus 1.96 times 0.0172. So we get 0.296 comma. So good. What is it?
0.3637.
Okay, so we'll do 0.364 or 0.3637. Either one's correct. All right, so construct a 95% confidence interval. The problem starts out giving it as percent, so we need to finish it as percent. So our interval is going to be 29.6% to 36.4%. Once again, it's not asking for an interpretation. It's just saying construct it, so that's the answer. If it asks you to interpret it, you would say, based on our sample of n equals 750, we are 95% confident that the true number of parents who play or take part in a recreational activity with their children on a daily basis is between 29.6 and 36.4%.
Do you have an extra nine?
Do I have an answer to that? Yes, but I'll get it to you in a little bit. And then number 4. A random sample of 19 women, so there's the numbers, that's how many we're looking at, has a mean height, so that's our sample average, sample mean, 63.85. Other studies have shown that heights are normally distributed with a standard deviation of 2.5. That's the population. Construct a 90% confidence interval. So we've identified that it's a Z interval, which means it's going to be X bar plus or minus Z critical standard error of X bar. So we've got to find all this information out. X bar, we know that's given to us in the problem. Z critical, if we don't know it, then we go to the concept, Z critical, negative Z critical. This is 0.9.
So is the T interval the only one you don't have to find the Z critical for?
Yes. If that's 90% of the data, how much is on the outside? 10%, so how much is over here to the left? 0.05, right? 5%?
Yeah.
So the total p-value is 0.95. So then to find the z-score, We go to our chart. We find 0.95. Either one, they're both the same distance from 0.95. I'm going to go with 0.9505. It's 1.6. And then following it up to the top, 5. So Z critical is 1.65. And then the standard error X bar.
1.573.
If you know the population, it's population divided by square root of n. We do know that. If you happen to know the population, okay, so here's the question. If you know the population and the sample, which one do you use? Population. If the problem, this problem gave us just the population, it did not give us the sample. If the problem gave you the population and the sample, you use the population. Because population allows you to use a Z interval. If you depend on the sample, you're going to have to use a T interval, which is not as accurate. Okay, it'll give you an approximately the same. So, but not exactly. So we're going to fill this in. 2.5 over the square root of 19. Handy, you said it, right?
0.573.
0.573. Okay, sorry. 574 or 5735, either one. So then to fill this in, it would be 63.85 plus or minus 1.65, 0.5735. And then you just punch that in. 3.65 minus 1.65, 0.5735. And then change that to an addition. So we get our interval is 62.9 to 64.8. So, once again, it just says construct a confidence interval. That's the construction of it. The interpretation would be, based on our sample of n equals 19, we are 90% confident that the true average height of women is somewhere between 62.9 and 64.8 inches.
And we